So performance is important. Then we integrate various software stacks. So we have tons of software stacks lying are outside in the market. We use like Linux, we use LK kernel, or we use FreeRTOS. We integrate that. But if you don't know how they are working, you'll never be able to even pitch your idea. Okay, boss, I can use this. I want to integrate this idea. You can never do that if you don't have the idea, right? So do the prep work now as a student. Okay, I mean, have a fair understanding. I would not expect you to be the master, but as in when you grow the career in your home, when you come back after 8 hours of your work, 8 hours of your work, again I'm repeating, come and do these. Do the prep work for your future. Don't do office job after 8 hours. You're paid only for 8 hours, right? Then deliver solutions in first go. It is a key attribute that you deliver in the first go, otherwise your appraisals are affected. Simple. Okay, and deliver on time, no scope of errors. All these are KPIs which are obvious. I don't have to explain this. Once you get into the job, you are expected to do this. All right, and then come up with unique ways to debug some kind of issue. So normally we think that connecting a debugger and then we can use debugging. No, that's not the right way to do every time. Yes, debugger is necessary to do some critical tasks, but if you're doing something innovative, right, you don't have to use debugger every time. Sometimes you need to have a shorter turnaround time also. Like I have got cases where I was dealing with no debugger because I have to get a debugger from other person, but I said I don't want to use debugger, and because company will also not afford debugger. Debuggers are very, very expensive and go up to lakhs in price. So they normally restrict you with using resources, whatever you have. And the timelines are given you like within 30 minutes you have to resolve this, otherwise the build is getting blocked or the release is getting blocked. So you need to come up with innovative methods. So practice now. This has to be practiced now in your college. And then as usual, document your work. I have discussed this earlier as well. So, school life, by school I mean even the college and the real life. All right. So, this is the clear cut distinction. Please understand and follow this very, very closely and understand it, the importance. All right. Appreciate the importance. So, we learn physics in college, in school. We learn about electrical circuits, power circuits like RC, variable loads, right? And then power measurement and whatnot. It is direct representation of your power subsystem domain today. So if you're designing some embedded system, you need to have idea about this. Only then you can design an electrical subsystem, right? So what we learn in school has a direct implication in this field. So please do not dismiss it. You can say I can learn it later. No, you are late, because these are certain things that are prerequisites. And many times the cases your interviewer also will not even ask because it is expected. But when you go on the job, believe me, if you don't know this, your appraisals are gone for toss. So you're expected to know electrical because that directly is a representation of your power subsystem design. You need to know electronics because that's how you design the interfaces. That's how you design your PCBs. That's how you design the coupling couplers. Right today in software, we also need to know how the power is getting coupled because coupling capacitors are necessary. If there are some signal coming out of the pins, right, you need to know exactly where to introduce the coupling capacitor. So that is necessary, analog and a digital system, right? Then you have kinematics and dynamics as well. Because if you want to come up with a solution for a unique problem, for example, let's say using my smartwatch, I want to track what kind of activity I am doing. You need to know exactly motions and some knowledge. For that, you need to know how your motions and kinematics and dynamics of your body, right? Direct representation. That's how you pitch the idea. Then light and properties. If you're using some kind of optical, let's say if you want to do some medical device which has to detect, corneal issues, same, right? So you need to have the basic understandings of physics. Only then you'll be able to apply it. Similarly, in mathematics, you use integration, differentiation, trigonometry, and geometry. They also have exact representation for signal analysis. Okay, so anything like signal sampling, error correction, recovery, all those have direct representation from your fundamental math. Yes, we are not taught how they are being used, but actually you should not be taught as well. These are applications. You're being taught science. Science and application are two different things, right? So make sure that you understand the science thoroughly, because your application will come only after you get into job. Nobody prepares you for that. All right. Then again, chemistry, you have atomic structures, then you have crystalline structure, element properties, same semiconductor physics, nanoparticles, because this is the area where that is growing. Today, nanomaterial physics is one of the leading areas where people spend a lot of time, right? So please ensure that you spend time understanding absolute fundamentals, because this is exact representation of your real life. The only thing is that you're applying there, you're learning here. And school is meant to learn, not to apply. Please remember that. So do as much as you can study the low level. See, as a student, as I said, you're expected to do all of this, and in your early ages, you are expected to do all of this as well, right? So make sure that you spend enough time doing this. Don't waste your time. And yes, this is real life. This is how it is. And I'm not making up things, because if you think I'm making up today, you will naturally realize it later. And when you realize it, it will be late. Better correct now. All right. So, yep, this is my session today. So, having said this, I would thank you for giving me this opportunity, and take advantage of this, whatever I've explained you today. And if you want to connect with me on LinkedIn, please scan this QR code. You can send me the connect request, and I'll be glad to help you out. All right. So, yep, thank you, ma'am. Thank you, RMK College. This has been good talking to everyone.
Yeah. Thank you, Akash. Thank you for being here and for giving this wonderful presentation. And it was really very impactful regarding the importance that you told about the documentation and to have a strong fundamental, and you have emphasized on the skill set uh, that the student should possess. It was really a motivating talk that hope all the students as well as the faculty who have joined this session would have acquired those informations from you, and hope so that the way you conveyed that how you need to have the Arduino IDE as well as the Vim editor, or how it should get connected with each other, and how to create the correct way of documentation, as well as you emphasized on the fact that the ChatGPT is not helpful at the lower level, so which the students actually need. And because these days the generation is like cut and copy from ChatGPT, will not
Yeah.
work in the real world. So thanks for emphasis on that. And I also would appreciate you to give away the importance of knowing about at least one architecture to have, like you said, risk five or any one which you the student should have an entire complete knowledge in terms of the system integration as well as the tool chain knowledge. And thank a lot that you have emphasized on the CPU optimized code, so
Yes.
which is very necessary these days, and
Correct.
the power performance area, which we emphasize on the hardware, and you mentioned that both the software also it require to have this knowledge before starting their coding. And again, you emphasized on this electrical, electronics, as well as kinematics and dynamics perspective that the students should be aware of, which may not be asked in the interview. They need to have an awareness about it. And
Correct.
thanks a lot for giving very impactful, was a very impactful speech, and it's a very necessity for this moment as the students are most of the electronics engineering students, those who joined are today, along with the other EC domain. Uh, this is very important for them if they want to start their career in embedded systems. Thank
Totally.
you, Akash. Thank you so much for joining us. Yeah,
Thank you.
thank you.
Thank you for giving me this
And
opportunity.
I thank all the audience as well as the participants here who joined this. And as Akash mentioned, if you have any doubt or if you want to clarify, kindly scan the QR code and you are feel free to contact him. Thank you all once again on behalf of RMK CET, Electronics Engineering VLSI Department. I uh, wholeheartedly thank you for all those who joined this session. Thank you once again.
Thank you, ma'am.
Yeah, okay.